Good morning, ladies and gentlemen. What a pleasure it is for me to stand here for you to open the session for Belgium on Stage. This is a collaboration that has been done with AWEX, the agency for export and investment in Wallonia, and Agoria, the technology trade federation. And this could not have been possible without the support of the Federal Public Service of External Affairs. So, my name is Kevin Poelmans. As a daily job, I'm working for Agoria, the Technology Federation, as business group leader for the composites sector. And so this leaves me to welcome to stage His Excellency, Mr. Ambassador for Belgium in France and Monaco, Mr. Jo Indeke.
Ladies and gentlemen, I'm very happy to open the Belgian on Stage event at this year's edition of the JEC Fair. It's only natural that Belgium should be at the start of this fair, as it was a Belgian chemist and inventor, Mr. Leo Baekeland, that with bakelite laid in 1906 the foundation for plastic composites. By the middle of last century, approximately 15,000 different products were being manufactured from bakelite each year, from telephones and radios to doorknobs, electrical outlets and printed circuits for electronic devices. Belgium has always been innovative in the field of composites, and its presence at the JEC World, the world's largest exhibition in this sector, with over 1,200 exhibitors from 106 countries and more than 40,000 professional visitors, is no coincidence. It has been almost 15 years since Belgium has been present at the exhibition. And since 2023, Agoria and AWEX have jointly organized the Belgian pavilion at the JEC Fair. Over 45 Belgian companies are exhibiting at the JEC World Fair this year, including 21 in the Belgian Composite Pavilion, which also hosts 3 universities, 3 research centers, as well as Belgian clusters and federations. And I all invite you to visit the Belgian Composite Pavilion. The expertise you will discover among our exhibitors is diverse, as are the diversified application domains of these technologies. In energy transition, with wind turbine blades, floating photovoltaic installations, battery housings, pressure vessels for hydrogen storage, and so on. Also in the area of new mobility, with urban air mobility, lightweighting for greater autonomy in vehicle electrification and optimization of transportation applications. Also, support for zero-emission aviation, composite bicycles, very important to a Belgian, of course. Also, with regard to defense, construction applications, industrial applications, so parts of high-speed machinery, as well as cutting-edge expertise in non-destructive testing or material and solvent recycling. And medical applications, such as prosthetics and orthopedic applications, radiotherapy support tables. All these are Belgian knowledge and activities we have here, and which are on show here at the multiple stands here at the JEC World Fair. I also would like to thank Agoria, AWEX, and the exhibitors for bringing together this fine example of Belgian savoir-faire and organizing the Belgian pavilion, as well as the Belgian Ministry of Foreign Affairs and Foreign Trade, who are financing this Belgium on Stage event. I wish you a very nice discovery of our Belgian talent, and thank you for your invitation. Thank you.
Thank you very much, Mr. Ambassador. Then we come to the next part of the presentation of today. So we're going to introduce you to the Belgian ecosystem. So the Belgian ecosystem, for this I have 2 presenters for you. So I call on stage Mr. Jan Verhagen and Mr. Stefan Galandries.
Good morning, everybody. I heard people talking about 10-year check. My first check was 30 years ago in Tour Lafayette, and I think there were 10 or 20 exhibitors. So it's a long way that check went. I'm the president of Agoria Composites, and I'm also vice president of the European Composites Industry Association. Which means that Agoria Composites is a small UCI. We implement everything that we hear and see in UCI in Belgium. So Belgium is a composite country, although we do not always show ourselves like that. But we represent 250 companies in Belgium, employing 6,000 people, and have a turnover of 1.6 billion euro. So Agoria Composites has 53 members, and most of them are here on the show. Agoria Composites is a special branch in UCI. UCI is a composition of all independent composite associations of every country. Agoria Composites is a part of Agoria, a technology group in Belgium, representing aerospace, automotive, a part of the chemical, building industry, machine components. So that means that we have direct access and connection with all kinds of industries in Belgium. So I like to say that Belgium is an innovative country, and if you look, we are amongst the highest ranking in innovation in Europe. So what I like to say is that we have 3 to 4 legs of the composites industry in Belgium. You have the big companies, the big producers, the big converters. You have the institute, the strategic research centers. We have at least 5 universities which are the top in composite in technology. And what is very important, we are an SME country. So SMEs in Belgium are very on its own. And it's the task of Kevin and me of grouping all these little companies under the umbrella of Agoria Composites. And we are successful in this. So that was what I said already. So this is an overview of all the companies, and I forgot how many of these companies are on the show.
53.
No, how many are on the show?
19.
19 are on the show, and I invite you to come and see the Belgian Composite booth, which is in Hall 6, and we have very interesting things to show. Is dat goed? Voilà. Okay, thank you very much.
Thank you, Jan. Hier nog hier zetten. Next on stage is Stefan Galandries, project manager at Skywin, which is the spearhead cluster for the aeronautical sector in Wallonia. Please, Stefan. Thank you.
I would like to present a few elements in the aero roadmap and share some projects, including Wings project. The main line of development focuses on the following objectives: continue on the development of weight-saving materials, continue on the development of technology to improve surface finish and to improve production processes, increase aircraft recyclability using more suitable processes, develop intelligent materials, enabling function to be directly integrated. They continue to develop existing skill in NDT to enable better integration in industrial processes. Next one. Voilà. The development of the following technologies will be taken into consideration. This list is non-exhaustive. First one, thermoplastic composites. The use of thermoplastic composites in the new generation aircraft should offer the same durability and strength as aluminum, while reducing the recurring cost of fuselage compared with the use of conventional thermoset composites. The key advantages of thermoplastic over thermoset composite are listed here. And further development should enable us to take advantage of the specific qualities of these materials and spread them more widely in the aircraft of the future. Second advanced alloys, lightweight, corrosion resistance, and mechanical strength have appear to be a key material in the aerospace industry. New advanced processing techniques will also help meet the needs of the next generation of aircraft. The last one is additive manufacturing. In the aerospace sector, additive manufacturing processes can help meet several industrial challenges. However, the deployment of this technology is more slower than initially anticipated. Further development will therefore be needed to reduce the limiting factor of additive manufacturing. I would like to speak about WINGS project. WINGS project is a partnership innovation technological project. 21 partners have joined the R&D force around the ecological and digital transition to actively contribute to the European Green Deal. Work package 1, 2, and 4 is about the point, the roadmap, about the roadmap. And finally, this one, I want to just to speak briefly about two current projects, Win4C and REPREC, you see here. And I stay for further information at the Skywind stand. Thank you.
Thank you very much, Stefan and Jan, for this introduction to the Belgian ecosystem. So we now come to the main block of the presentation of the Belgian on Stage session. Thank you, Jan. And for this, I have to call on stage 7 people. So I would like to call on stage Caroline van Broekhoven from Vito, Lucie Souvie from Isomatex, Axel Zeifert from Sharp Composites, Wim Six from De Koning. Still waiting for the rest. Mr. Laurent Hazard from Science School, Ms. Linde de Vrieze from CIRIS, and Mr. André Bertin from Co-Expert. Thank you very much for joining me on stage. So first on stage is, I will go to the next slide, is Caroline van Broekhoven. She's research manager for sustainable chemistry and materials at Vito Research Center in Flanders. And she will love to talk to you about her new project that she's working on. Thank you, Caroline.
Thank you very much, Kevin. So happy to be here. It's my first time. So I'm going to talk to you about our live project. It's called Viable. and it stands for valorization of lignin biomass into competitive components, gradually replacing bisphenol in the formulation of epoxies. So as you can see, in the middle part, we cover a big part of the value chain. So we start from biomass producers, where one of the biomass components, it's called lignin, is actually the essential component that's being delivered. Then we modify it, and then it's being used to formulate into epoxy resins, which are being used then to make final materials and also finally integrated in a car. So the whole project aims to really get a prototype of a car where actually the lignin-based resins are used both for structural and aesthetic components. So as you can see on the right side, we are with different parties. So Vito is the coordinator, and we have Westlake, Ciensco, Stellantis, HP Composites on board, next to some parties who support us on the overall communication. So why are we doing this actually, working on lignin-based epoxies? It's because if you look to the epoxies, of course, a lot of you, I guess, know, it's being used in a lot of different materials, from aerospace, till electronics, till windmill blades, till car components. And one of the car components, let's say chemicals in these epoxies, is actually GBA, which is derived from bisphenol, as you can see in the scheme in the middle. And it's a growing market, and we see that there is a need to get more sustainable products, because if you look to the current bisphenol being used in these epoxies, it's actually currently derived from fossil resources. It's a big production globally, up to 10 million tons. It's an essential component in this formulation of epoxies, because of course you need the strength in these materials. But of course, if you think about bisphenol, there is some regulatory, some health issues related to it for some specific applications. But to, let's say, really be ahead of it, we are looking into replacements of this bisphenol, which are also safer, next to bio-based, which then also results in a lower footprint. So the challenge is to make it more sustainable. That's why we look to bio-based materials, and also safer. So our approach of the project, we look to a replacement of bisphenol by 25 up to 50% by introducing this bio-based alternative. So we look to different resources. You see it on the left side. So it's derived from different botanical origins. So looking to wheat straw, hardwoods, different types of original biomass sources from which lignin is isolated. The lignin is then depolymerized to make it more like a handleable chemical, because you really need a defined chemical to introduce it into these epoxies. Then a modification is done to introduce it into the epoxy resin, and that's then further formulated into a pre-preg and then into a prototype for automotive. And you can see the picture on the right side, where indeed is being, let's say, developed for two types of components. One is a structural one and an aesthetic one. How do we do this? Making this, let's say, bisphenol substitute. So we actually look to lignin as a component, and then we developed it from lab to pilot scale to be able to deliver enough material, because the final aim of this project is to deliver up to 300 kilos of epoxy resins. And if that works, we have a validation at the pilot level. So that could be, let's say, the go to go ahead and to go into bigger demo production. So you see, we started from lab and we moved into pilot scale, where we have 2 units which are able to produce up to kilo per hours of this depolymerized lignin, which is then further modified to be used as a bisphenol replacement. The future perspective and potential of our development. So yeah, we are currently delivering the replacement to our partners who are formulating it into the materials, and then this is how we gradually build it over the value chain. So is it a bio-based alternative that's viable, economically viable as well? Is it available? It means, can you rely on different providers? Is the alternative safer? It's also part of our LIFE project to really look into the toxicity aspects. Is the upscaling of the process reliable, reproducible? So can we deliver quantities which are okay in terms of time? And does it also, let's say, not affect the material performance? Because in the end, that's what you want, a replacement which ensures that the performance of your material is still the same. Thank you very much. We will be at the Belgium booth today, so if there would be any questions, I would be happy to answer them later on. Thank you.
Thank you very much, Caroline. Next on stage is Miss Lucie Souvy. She is project manager and quality system management responsible at Isomatex, where she is responsible for ballistics and sporting goods and thermal applications, if I remember correctly. So you can also, there's always a mentioning on the slide of where to find Isomatex and the other companies that are presenting today. So without further ado, I give the word to Lucie. Please.
Good morning, everyone, and many thanks, Kevin, for the introduction. So I'm very delighted today to present to you our company, Isomatex, obviously based in our beautiful Belgium, and I'm really honored to present how innovative we can be. What we do at Isomatex, well, we are a mineral fiber manufacturer that has been innovated for the last decades, more than a decade now, to create a high-performance mineral fiber that is used as a reinforcement in composites or in technical textiles in many types of applications that I will show you in a while. First, I would like to mention that we do not produce glass or basalt fiber. Yes, plenty of times we are mistaken for basalt fiber, but we are not. Our recipe is very innovative in a sense that we've been stabilized it for almost 15 years, and we have different mineral ingredients that we add and to enhance the performances of the fiber and to really ensure the safety of the user. You will hear it a lot during my presentation, but the name of our product is called Filava. Of course, due to the fact that our industry and factory, more precisely, is quite modern, we made the choice at a very early stage to choose sustainable and renewable energy as a really key aspect of the creation of our company. So we have 100% control of our LCA internally, which is, and I'm really proud, very good, thanks. And well, we made some different approach in terms of our manufacturing process. Firstly, by choosing electromechanism to heat up our furnaces, but also the fact that all our raw materials are coming from Europe, and more precisely Belgium and Germany. And we are a monosite, so everything is located in Belgium, near Namen, near Namur. And we have our R&D, production, quality lab, etc. And also our partners are European, because we are not only producing bobbins, but we are also producing woven fabrics to semi-finished products, to pre-preg, woven fabrics, hybrids, needle punch felt, etc. So we have a large list of European subcontractors that we trust since then, yes, more than a decade or so. And also these very aspects are obviously chosen for a reason, to reduce the CO2 emission with the transports and be as green as possible. And to showcase also the recyclability of our fiber, I chose to present you a really interesting project that we've been done 2 or 3 years ago, which is the recycle of a boat that was displayed at the Very Jec a few years ago, and now is not seeable anymore because we have recycled it entirely. And we now really, control the process of the recyclability in-house, and which is a very important aspect in our manufacturing approach. And so we do a solvolysis and a pyrolysis, meaning we put back the fiber in our oven. We can do that only because we have a really very strict quality control process throughout the entire life of the manufacturing process. So we are able to do that because we are controlling everything. But our fiber is not only used for the recyclability and the sustainability aspect, but also and obviously for the high performance of the fiber. You can see quite a few characteristics that are really important for us, such as the mechanical properties, because we are in the range of carbon fiber, but also the impact resistance, the shock absorption, UV resistance, also the thermal insulation of the fiber. And to that, we have now extend all the versatility of the fiber, and we are now able to provide our fiber to the most critical and high performance application on the market, which you can see here, a little bit of the list. Obviously, we are an aerospace grade fiber, so we are obviously in the aerospace. But not only, we are also in the naval, in the marine industry, in the sports, in the ballistics, defense, safety, mobility, renewable energy. And all these applications are really made for us to enhance the security of all the users, from a car to a plane, to an helicopter, to a yacht, etc. So I would like to invite you to pursue this conversation with me if you have any question. Our booth is located in Hall 5, M108. This is the number of the booth, and I will be very happy to meet you there. Thank you very much.
Thank you very much, Lucy. Next up, you already knows the cue. Next up is Mr. Laurent Hazard, who is the head of material center at an application center at ScienceCo. And he will tell you a lot more about his capabilities in Brussels. So,
thank you, Kevin. Laurent. Good morning, everyone. I represent today company ScienceCo, which is a brand new company in the field of materials. So ScienceCo was born from the split of former company Solvay, a very old chemical company with more than 160 years of history. That company was split into a specialty materials company, which is ScienceCo, and an essentials company who was keeping the name Solvay. So ScienceCo is divided in several business units, but I'm part of what is called a growth platform. So we currently have 4 growth platforms that are aligned with the mega trends and the challenges of this world. So today, 4 platforms. The first one is battery materials. The second one is green hydrogen. The third one is renewable materials and biotechnology. And finally, the platform I belong to is called thermoplastic composites. Those platforms have in common that they are like a small business on steroids, with the goal to really deliver a lot of growth for ScienceCo, but also to invest in innovation at an extremely fast pace. So within the thermoplastic composite platform, I'm leading a team, an R&D team that is called MSAC. MSAC stands for Material Science Application Center. It's based in Brussels, so in the center of Europe, and it has an interesting mission because it has a dual purpose of both being a customer engagement center and a center of technology excellence in thermoplastic composites. So customer engagement center, that means that we are not working behind closed doors. We want to open and even have open access to our labs and capabilities to our customers. We want them to come over. We want designers, we want material engineers to come and experiment with us on our equipment, or our materials can be used, leveraged to develop new products. So we do that based on 3 main pillars. The first one is called prototyping, and it's everything that you can imagine to build a part. So you start with maybe a roll of tapes, or you start with top regs, and you need to process them to end up with a final part. We are slightly different from our competitor in the sense that we have big machines that you would typically find at our customers. So an example of that is a big wicker press, 500-ton wicker press to make big aerospace type of parts. We also have a second pillar that is called performance, where we do a lot of testing, both fundamental at the specimen level, tensile bars, for instance, to understand really the behavior of the materials. But we also do part testing, so assemblies, we can test complex parts at a big scale. To bridge both pillars, we have a strong virtual engineering and design team working on modeling and simulation. So they work at the fundamental scale, they work on taking the experimental data that we generated at the tensile coupon level to create material cars, to feed into the simulation workflow. And then we do simulation both of the forming capabilities, but also of the function capabilities. To exemplify that a little better, I selected 3 different projects we are working on nowadays. So the first one is related to a European-funded project called LTPLA. The biggest partner there for us was Airbus Helicopter. And it's actually an emergency door, not for an helicopter, but for an Airbus A320. So Airbus Helicopter dedicated engineering resources to that project in support of Airbus Aerostructures. So what we did within MSAC is first do a lot of simulation to define the tooling to really achieve a zero defect part. Predicted the wrinkles and every kind of defect that you can have processing our thermoplastic composite, in this case APC material. Based on this simulation, we defined the tooling and we worked with a company in Belgium to get the actual physical tools. Those tools were then used in MSAC, still in Brussels, to manufacture parts, so structural members that you see, and those members were then machined in Jet Techniques in Belgium and then shipped to Airbus for the assembly of prototypes of the doors. You can see a small picture on the left side of the door, of one of the doors that was assembled. If you are interested to see it and touch it, it's also shown at the Science Co booth in Hall 5. It was a very interesting project in the sense that all the pillars within MSAC aligned to deliver on the final goal. And it's really a nice experience to be able to feel the parts at the end of the whole process. The second project is called Compost. It's a project that is sponsored by the Brussels region, and we have several partners. Some of them are here today. The Vrije Universiteit in Brussels, Université Libre de Bruxelles, but also UC Louvain, academic partners. And we are sponsored, as I said, by Innoveris, so the Brussels region. This project was born from kind of a strange feeling. We were unsatisfied with the answer that we provided to our customers around recyclability. What are you doing with your waste? The tape that you waste, maybe the scraps around the blanks after machining. What are you doing with them? The answer was always, well, you can compound them and then you get a nice engineering compound. But we never did it ourselves. We worked with partners and so on. We knew it could be done. So now within this project, since we have all the tools internally, we have compounding lines, we have everything really, we want to use one of the parts that we developed in a previous project that happens to be an hybrid part, so it's the part in blue. So it's hybrid because it has a thermoplastic composite backing, and then it's overmolded centrally with a lot of ribbing with short fiber engineering plastics. Our goal in this project is to define several paths, several recycling paths, where we want to remake the compound or remake the laminate with basically the scraps and the wasted material for the whole process. But we don't want to stop there. We want to actually do all those paths, all those scenarios, and be able to put a cost tag on them and a performance tag on them together with the life cycle assessment. So that's an interesting project. We already have triggered the interest of Airbus because we are now working on the following the follow-up project of LTPLA, which is called Tavida. And since they know about compost, they want us to apply the same recipes that we developed in compost on Tavida as well. Oh, sorry. The next project is related to the hydrogen disruption. So we have a lot of people right now working on testing equipment for hydrogen, talking about cyclic pressure testing, but also permeability testing at temperature, and not just on simple plugs, but tested on pipes and on pressure vessels. So we are essentially working, the project is called ISTER, we are working on transportation of hydrogen, so piping, but also pressure vessels, small ones for mobility, but also large ones for storage, temporary storage of hydrogen. So you can see highlighted the different stage gates. What we are trying to achieve right now is what we would call generation 4.5 of the tank, which would be a tank with a structural shell made of thermoplastic composites and a liner also made with a thermoplastic, ideally compatible and achieving being an answer to all the challenges of hydrogen. If you want to know more about what we do in TPC, but also in thermoset composites or in hydrogen, there is an interesting project that we just started called Be the Impulse. Well, actually, Be Impulse is the hashtag. The project is called Climate Impulse. It was born from the ashes of a previous project called Solar Impulse. The goal is very challenging. The goal is to build an airplane that would go all around the world in 9 days, only propelled by hydrogen. So MSAC is involved and will provide the materials, but also the part for that project. Thank you for your attention.
Thank you very much, Laurent. Perfectly on time. Thank you. We continue in the mindset of processes. Processes are very much important in the world of composites. So I'm pleased to have Mr. André Bertin from CoExpert, CEO of CoExpert, on stage. We will love to tell you more about this technology, RTM, and ask you RTM.
Okay.
The floor is yours, Mr. André Bertin.
Thank you. So today I will speak about science of composites, we at ScienceCo, and then science of equipment. So as my partner, Dimitri Shmidovic from USA, like to say, there is really key parameters to control when you want to make a composite part. What is important to understand with composite, you generate the material at the same time you generate the part. One key point is porosity. To avoid porosity in a part, you need really to control the resin hydrostatic pressure, and you need to control it independently from the other parameters. The 6 key parameters Dimitri like to remind: time, temperature, and vacuum. Autoclave control these parameters. But the other parameters, the ply thickness, really what will be the thickness of your part, the fiber bed pressure, the pressure on the fiber, on the laminate, and the resin hydrostatic pressure, the pressure in the resin, have to be controlled independently. And that do not work in an autoclave. And it will never work. So we went together to net shape process. We are in RTM business or SQRTM not because we are fond of RTM. It's because we want to be in control of the key parameter of the process. And with a closed mold, the fiber bed pressure is controlled by the pressure of the press. The volume fraction is directly controlled because you have a 2-side mold, so the gap and the thickness of the part is frozen. The resin volatile, we can highly degaze the resin and we can control the vacuum in the mold. So it's just compared to autoclave, we want to be in control of the key parameter that the scientists say you have to be in control if you want to make a good composite part. And from there, from these basics, we developed the right equipment to do it. It's why 30 years ago, Dimitri and Radius Engineering invented a piston to control the pressure on the laminate and to inject resin, not a pressure pot. And behind the science of the process, there is the science of the equipment. Today, we are the largest supplier of RTM equipment to the aerospace business, with hundreds of equipment in production only in aerospace for highly intensive production. And as an example, we propose mold in aluminum for high production rate. Why can we propose that? Because we manage the CT mismatch between aluminum and carbon fiber. You see here an illustration of an 8-meter long UD part in tape When the mold expands, the aluminum mold will expand by 2 centimeters. The way the laminate move is somehow pulled through that. With the tool expansion, we can control it, we can predict it. So we don't need INVAR. And the durability, you need to repair your mold. And I just illustrate here, you have mold samples. We remove the material, the surface treatment, and we put it back. It's hard anodization. So we have solution not only to provide very large mold in aluminum, an aluminum solution, but also to repair and provide maintenance. And we work with universities since 15 years, understanding what is cracks in anodization, what is the microscopic structure. So all our equipment is based on science. We want to know every detail. What do we do with that? A first game changer, the A320 RTM spoiler. Spirit Aerosystem contracted us to develop a new version of the air brakes of the 320. There is 10 air brakes per aircraft. At 60 aircraft per month, it makes 600 parts per month. It was moved to Malaysia in 2006, from Scotland to Malaysia to cut the cost. Spirit came to us 5 years ago. We imagined a new solution, a new architecture, and together we raised the technology readiness level and the manufacturing readiness level in our shop at CoExpert. It's dedicated to that. We don't do serial production, but we mature the technology and the manufacturing at the same time. So in less than 1 year, we proposed the spoiler, we developed the spoiler. You see the team with the first spoiler. We have produced the first one, the first series at CoExpert, before we install the full set of equipment in Presswick with 7 presses, tens of molds, injection system at the core of the shop, which is the most automated composite shop anywhere in the world. What does Spirit claim today? It's relocalized from Malaysia to Scotland, and it's 30% cheaper with CoExpert equipment, with CoExpert technologies. This is RTM. We have another process, SQRTM, where we cure legacy prepreg. With Turkish Aerospace, we have developed aileron of the 350 in SQRTM, one shot, out of autoclave. It's a process qualified as equivalent to autoclave. This is the only process today qualified as equivalent to autoclave out of autoclave. And you see here the mold is quite a box, not complex shape. So what happens when you want to make a complex shape or a big shape? Let's think, we just need to control key parameters. So let's imagine the equipment that will put us in control of the parameters. So for Airbus and FIDAMC in Spain, we developed an equipment and a solution to make rear spar in Wing of Tomorrow. It was published at SAMPI in Madrid. It's an innovative equipment. The part has a kink. It's a V-shaped part. So to minimize the mass of the mold, let's make a V-shaped mold that follows the shape of the part. And the press is also a V-shape. So we have a side loading and we have a very light mold. And why not in aluminum? So we made a 12-meter long mold in aluminum with junction in the middle, but with very high vacuum. So we just inject from one inlet, one outlet, and we get the part. Very simple process, very basic philosophy. It was published in '89 in Tempe, California, use aluminum mold. It just scale up. We follow the size of the part. And then what about a big skin panel? Also, Airbus said, we deliver this press to Airbus in Germany. It's 9 meters long, it's 4 meters wide. The mold is 40 tons. It's a very innovative way. The mold is 2 shells that follow the shape of the part, which is clamped in a press, suspended by a cold grid. We just heat up 2 shells that make the RTM mold. The press is 4,000 tons. It's the largest RTM equipment ever built for aerospace application. It just works because it's science-based. We just reproduce and scale up all the ideas we pushed since 30 years. So you see today we are with movables. We can do RTM, we can do pre-preg in out of autoclave, but also we can scale up to any size of part. And what is important to understand, such an equipment cut the energy consumption by 10. It means on such equipment, if you take 10,000 aircraft to produce, your cost saving in energy is 100 million. It's huge. Just on energy, the equipment pays by itself. But you also save on the resin, you save on the quality. You cut your waste, no more vacuum bag, no more plastics. You cut the waste by 50. Maybe you will go for hundreds of tons of waste per year on high production rate to just a few tons, which is just the seal and which is recyclable. The takt time, the time you spend your equipment is cut by 2 or 3. We make hot loading of the material, hot demolding of the part. We just use the high capex, just short time. We cut the tolerance by 10. The stiffener is located at 0.2 millimeters and not 2 millimeters. So the assembly is a lot cheaper. And we cut the cost of the part maybe by 2, because it's a lot more prone to automation. At reduced weight, we can go to a little bit higher volume extraction and reduce and increase quality. And you have 2 good surfaces. Last one, deposition of material is really key. We speak about net shape. The location the fiber is put in the mold is really primordial, because the mold will expand. So I started another company named Co-Expert Dynamics in partnership with Trelleborg Sealing Solution Albany, which was automated dynamics. And we look at fiber deposition, automation. We work with Siemens on very accurate solution for fiber deposition, because we want to close the gap between the preform and the molding and provide a solution where net shape is done from the fiber to the demolding. So you're welcome to our booth, and I will be very happy to answer your question.
Thank you very much, André. Next, so we already had a couple of presentations in this session for Belgium on Stage, where we want to show our savoir-faire, as the Mr. Ambassador said, to bring the composites that they can deliver a more sustainable future. We already had some presentations on raw materials. We saw lignin-based, we saw thermoplastics. We also saw processes. Now we come to another point which was already touched, which will be presented by Mr. Axel Seifert, who is CEO from Sharp Composites. And he will talk about how he will make the world greener with hydrogen. Thank you very much.
Thank you, Kevin. Yeah, thank you for having me here. It's not the first time I come to JC. I think Jan Verhagen mentioned he was 30 years ago already here. I think I was here with him. It was much smaller than now. Kevin, thank you for the introduction. Hydrogen storage. I think these presentations about sustainability, and obviously hydrogen plays a large role. And if you wander through the aisles of the show, you will see a lot of hydrogen tanks. And actually, Flanders plays a big role. For those of you who don't know, Flanders is the northern part of Belgium. I've been living there all my life, except the first 5 years. I was born in Germany, I still hold a German passport, but Flanders has always been very good to me. And actually, I started several businesses there to focus on composites. First of all, I would say 1990, the Cadwine software, which we wrote, was the first commercially available software for filament winding. And it's actually still the software being used by Toyota to develop the hydrogen tanks for the Mirai cars and the other hydrogen tanks they are developing. So it's still active, although it's more than 30 years old. Further step, a company which contributes to the technology of hydrogen storage is the company Covis. I think in 2004 they won an innovation award for their thermoplastic pressure vessels, which at the time were more dedicated for low pressure water application. Now they're also looking into hydrogen storage. Then I started a new venture, Composite and Optimum CPV, businesses to really focus on the development of hydrogen tanks. This was 2010. Was quite successful. I think today around probably more than 80% of the tanks you will see here, they have been wound using the composite software. So it's really very important piece of the technology being supplied to the industry from Flanders. Company Common Sense, also you can see them at the booth in 2012 or 13. We already integrated optical fibers in tanks to have a way to monitor the structural health of the composite. And then, 2017, Plastic Omnium acquired the Composite and Optimum CPV businesses, which is now the World Development Center of Hydrogen Storage Tanks for Plastic Omnium. And actually, Plastic Omnium has a production plant in Herentals, close to Antwerp, where you had the first dedicated production line of hydrogen tanks, which is obviously still running. Since 2019, they are producing tanks for a major bus supplier in Germany. I would say another company, although they are not using tanks from Flanders, they are into manufacturing buses. Van Hool, also running on hydrogen. And Sharp Composites, this is my new company. Again, we're teaming up with IMS Robotics to look at the next generation of hydrogen storage tank, being obviously more efficient and also more sustainable than what has been there today. Our competence is obviously filament winding. It's what we did all since 4 decades. Numerical simulation, it's a key element of the technology to really being able to assess the performance of the tanks. And obviously also robotic production equipment. Producing those tanks really requires a high productivity to be able to fulfill the requirements of the automotive industry. And then obviously we're extremely well connected in the network of hydrogen worldwide. Just a few words about filament winding. So this is what I did basically all my life. And I thought, well, first of all, it's an automated process, which means that it's repeatable quality. Out of autoclave, it's a very simple process, and you have for composites extremely high productivity of very high structurally loaded parts. It's an additive manufacturing process, and I think this is extremely important to know. Maybe you heard that BMW stopped the production of the i3 and i8 cars, and it was simply because they were too expensive. But on those cars, I think around 35 to 40% of the carbon fiber material was actually scrap. Okay, this we don't have in filament winding, where you can really use the carbon fiber until the last gram of the spool. And also, obviously, in those tanks, there's no finishing required to deliver the product. Filament winding allows to use the materials in their cheapest form. So the spools we're using in filament winding are those spools coming out of the carbon fiber factories. And obviously the resins as well, they're basic resins, not very sophisticated and relatively inexpensive. And last but not least, definitely in filament winding, you can use the directional properties of the fibers, meaning to put the fibers in the orientation you need for your application. Composite pressure vessel, actually, it's for those who want to have a look inside. So as I said, there are many on display. Key functionality definitely is the liner. I will have a few slides also on the liner production. Then the composite, some metal pieces for holding the valve and doing the load transfer between the composite and the valve and the piping. And then obviously the carbon fiber reinforcement. If you have a look at this, it's extremely simple. What is more complicated is actually, well, besides of the windings, to manufacture the mold. There also we team up with AMS Robotics They have a very innovative liner manufacturing methods, also used by the automotive industry worldwide to manufacture the liner, so the inside bladder of the tank. It's a patented technology, extremely accurate in controlling the process, and also suitable for a variety of polymers which can be used as liner materials. And obviously also there you're able to integrate the metallic in pieces. Furthermore, IMS Robotics offers turnkey solution for composite overwrapped pressure vessel production. And you can see a floor plan, but I'm sure that Johan Potargent is here as well. You can talk to him at the Belgian pavilion, and he'll be happy to answer all questions regarding manufacturing of pressure vessels for hydrogen. And I see I have half a minute left, and I would like to thank you all for attending this presentation.
Thank you very much, Axel. We see also that the composites are playing more and more role in building and construction and making this, this market also greener. So the next one presenting today is Mr. Wim Six from the company De Koning, where he is R&D project manager, expertise in extrusion and tooling, if I'm correct. He will tell you more how De Koning is introducing thermoplastic composites into window frames and how this will be the new thing of the future. Please, Wim.
So thank you, Kevin, for the kind introduction. So indeed, I will give you a brief introduction of a project. We did a Flemish project, which is called ProUD, of Proud we call it, which is on the implementation of unidirectional tape and toe-based pre-assemblies for hybrid processes. It's actually a collaboration between the Koning, Sioen, the reusable series, and the University of Leuven, where we had the goal to do some exploration of the matrix materials for UD reinforced tapes, but then basically what is fitting for our PVC profiles. Of course, we also wanted to use this UD reinforcement in injection molding, so that's why DW Reusables is also in the project. And of course, a very important thing is to have improved process stability if you are using UD reinforced profiles. Next to that, we also want to have the quality, of course, and that is why we need to have the prediction of the adhesion between the UD tape and the thermoplastic PVC, which is the rest of the profile, of course. On the other hand, it's also important that we have a good impregnation of the UD tape during the manufacturing, so that we have a good and stiff product at the end. Of course, if you are combining different materials, you all know that we have warpage of the in our case, profile or thermoplastic part. And of course, we want to predict that as we want to have straight window profiles. Otherwise, it's difficult to create a window with it. So the challenges for us is basically combining a good process stability, but also having a good product quality and keeping up the production speed, because we want to have a lot of window profiles. The price cannot be too high because it's a very competitive market. And if you want to have both all these three factors as high as possible, or you often lose on one of them. For us, what does it mean to have a good process stability? Well, we want to have at least a 14-day production run without stopping. So this, I don't know if you can, but the window profile, you can see it on the screen. And so the glass fibers are on both sides of the PVC profile, and the production of this PVC profile runs for 14 days without any stop. Of course, it's also important that you have very small tolerances, because a window profile needs to fit with another glass bead and a frame which has to be installed in the wall. Everything has to be wind and watertight, so tolerances cannot be too high. And of course, as I already mentioned, you want to have a good impregnation, otherwise you will not have the optimal quality in your window profile. And you cannot imagine how complex the load cases are for a window profile. On the first hand, you have the temperature loading. In the winter, -20, and the summer, even up to +80 degrees. But also you need to keep up the structural integrity, keeping up triple glazing windows, but also a large wind load. Storms often occur, and of course your window cannot fail. After that, you also have the aging of the PVC and of the profile, and we give a 20 years guarantee. It even goes up to 40 years in installation. And at the end, you also need to have a good impact stability of the profile. So why would you use these glass fiber reinforced profiles? Well, the first thing is that you have a better thermal efficiency, because you do not have large chambers inside, because there is no steel needed to have the stiffness of the window profile. So more internal chambers mean a better thermal efficiency on insulation. On the other hand, you also have the side of the window manufacturer, which do not have to have a stock of steel profiles which he has to insert in the window, in the profile, the PVC profile. So which leads for him to a more efficient and a simpler process. And a big benefit of these profiles is that they are easily recyclable. We at the Koenig, we have developed an own recycling line to recycle PVC profiles, but also to cope with the glass fiber which is in these PVC profiles. And we have proven that we can recycle them up to 8 times. So if you look at the case study of the UD reinforcement, we learned a lot during this project on the impregnation behavior and on the process stability we can gain. So here you can, for example, see in the bottom 3 pictures that of trials we did at pilot scale, showing the effect of temperature, of line speed, of impregnation pressure on the air pockets which are in the profile, in the glass fiber tape. And of course, we all know air pockets mean low quality. So we can, if we do not control the process well enough, we end up with a lot of air pockets. But we can, if we control the process, we can go to almost no air pockets. 0 air pockets is almost impossible in our case, but this limited amount of air pockets is more than enough for us. We also implemented a lot of numerical simulation in predicting, first off, of course, the cooling behavior of these profiles, but linked to the cooling, you have the stress buildup because you have different CTEs, glass fiber versus the matrix versus the PVC, which tends to warp the profile. So we, of course, need to tackle this. And it's very important that we know the effect of the glass fiber tape inside the profile. A little bit repositioning the tape can lead to a completely different warpage of the profile. As an example, on this complex profile, only a movement of 1 millimeter of the tape immediately gives more than 2 millimeter different warpage in another direction, which is of course not allowed. So at the end, we can say that via a lab scale and a pilot scale line we built together with the partners in this project, we were able to learn a lot more of the process of the UD reinforcement and the window profiles. And so we were able to increase the line speed by 20%, and of course also with increased production stability. Furthermore, we increased the stiffness with 10%, which is also very important if you want to go to larger window frames. And at the end, we can say that we now have better insight to develop new product ranges, which is of course what we want to do in the future. Thank you.
Thank you very much, Wim. So last but not least, on stage, I would like to invite Linde de Vries, Ms. Linde de Vries from Sirius, where she is project leader for composites, working also on circular economy as one of the main topics. Because, of course, when people talk about composites and circular economy, they generally tend to forget all the benefits that composites bring in a circular economy and only focus on the points that are still in need of some more development. And when we talk about this is talking about recycling. And so also on this we have a nice presentation that we want to give, and that's on the C-Blade project. And I give the floor to Linde.
Thank you, Kevin, for this nice introduction. Thank you all for your interest in what we are doing in Belgium with all the presentations we already had. And I'm happy to introduce the last project to you. And I would like to focus on recycling of wind turbine blades. This project that I would like to talk about, it's called C-Blade indeed. And it is a result of several projects that we have already performed in the past. We started at Sirius. Sirius is an innovation center. We started in 2016 with a first feasibility study, looking at the question, what will we do with all the end-of-life glass fiber reinforced composites that will become available in the near future. We did a feasibility study for OVAM, and we saw that after this study, it was picked up by the industry, and so we keep working on this, this topic. So the first feasibility study we did, we looked at the numbers, of course. What is the context of this topic? What is interesting to look at? And you see here in this slide the numbers for Europe. And you see the glass fiber reinforced plastics waste for Europe in the first graph. And for example, in 2030, the industry will account for more than 100 kiloton glass fiber blade waste in Europe. This is only 10% of the fraction. This is only 10% of the total fraction of glass fiber reinforced composite waste. In Belgium, we also have this rise of end-of-life materials becoming available. Of course, the numbers are smaller, but they are there and they are increasing steadily. So now at the moment, the blade waste that we know of comes from the onshore industry. In the next years, we will also see volumes from the offshore industry. At the moment, 2,500 tons per year. For offshore industry, it will be 10,000 tons per year in 2040. And like other countries in Europe, we are also looking in Belgium on how to tackle this increase in waste stream. So the Seablade project is a 3-year project. We are at the moment in the first year. So we just started with this project. And the aim is to energize and to build a Belgian value chain for recycling wind turbine blades. Important to note here is that we look at the short term. We really want to support the smaller companies that already are active in this field or want to be active in a short notice. So we look at a timeline of 5 years. And also important to note is that we want to find a route that is commercially also achievable, not only the technical side. So what is very important to us is that the project is industrially driven and also that collaboration over the whole value chain is facilitated. How do we do this? This is the material stream that we have in the project. We are focusing on mechanical recycling. So that means that in a first stage, we shred the blade and afterwards we will compound it. And the last step is then to make 6 products. These can be new products or already existing products which incorporate the recycled fraction inside of the product. At the moment, we are in the first building block, still looking at how to cut and how to shred the windmill blades efficiently so that we can retain the glass fiber with as high as possible material value. And this topic is studied by ReproCover and Revimax. ReproCover is looking at the shredding technology and Revimax is looking at how to cut the whole blade in pieces of meters long. And then at the end, we have the 6 end users, which is also shown here on the slide. We are supported. We think it's very important to have a value chain, but also supporting partners that are also busy with this topic and interested in how to support this value chain. So once we have ended the project, that we can start implementing right away. The Port of Ostende is a very nice example of this. They have, at the Ostende, they have the port, they have place there where they could possibly collect the offshore wind turbine blades and then start working on them to implement them in the product. The current focus of the project is twofold. first place, we are looking at value chain aspects, so assessing economic feasibility and also identifying possible extra partners for the project. And we also, in the second place, we have a technical aspect we are looking at, as I already mentioned. At the moment, we have finished the first small-scale test of shredding the blade and evaluating the granulometry of the products and evaluating them in the context of the end products that we are developing. And in the next few weeks, we will start with upscaling these tests that we have already done, going until 10 tons of material. So this is where we are now. I would also like to mention where we will go next, because of course, when we talk about recycling, we would like to have as high as possible material value in our end products. And we are very much aware that there are nice technologies like solvolysis and pyrolysis, or a combination of those technologies that in the future will become more and more feasible. They will also be more and more available, and we need some research still on those. So we will start, if we are funded, we are still waiting for the results, but hopefully we will start in the very near future a project on indeed pyrolysis and solvolysis to look also at long-term solutions where we will be able to handle all these materials that will become available in an efficient way. And this we will do together with the University of Leuven and with Vito. So feel free to pass by our booth, and I would be happy to discuss this further with you. Thank you for your attention.
Thank you very much, Linda. And this comes to the end of the block on different research centers and companies that showed the Belgian innovations that they are doing in a way that we want to make not only the composites industry, but also the markets, the composites markets, more green, more sustainable for the future. So I would like to ask you all to join me in a round of applause for these 7 incredible people. And then we come to the last part of this session. So please. So for the key takeaways, it is also my pleasure to call on stage, which I can call now a friend, Martine Leclerc from AWEX, where she's Trade Counselor.
Well, dear all, good morning, and thank you very much. I have the difficult task to end up this conference. So first of all, I hope that you enjoyed it and that you learned a lot about Belgium and its ecosystem and how the country is actively contributing to make the EU Green Deal happen. You know that we need more resource-efficient composites, we need more resource-efficient processes, we need to recycle more, and Belgium has been at the forefront in each of these topics and in most of the value chain of the composite. So whether you look for a research partner, whether you look for providers in Belgium, equipment of material providers, whether you look to invest in Belgium, please come and talk to us. We'll be at your disposal 30 minutes until noon here, right at the left when you leave the conference room in the speakers meetup room. It's like 10 meters from here. I also would like to invite you all to visit our Belgian booth, which will be in all 6R32. So I repeat, all 6R32. We will have the Belgium country on stage cocktail. So please join us at 12:30. And finally, I would warmly thank all the speakers today for joining us. and more specifically Agoria Composites and Wallonia AWEX for making this happen. And finally, and last but not least, the Federal Public Service of Belgium for their support to help us promote our ecosystem. So thank you all, and welcome to speak to us there in the speakers meeting room. Thank you.